Alright, number 3 is coming from section 7.3, the definition of a parabola from the focus in Directrix. This is part A is taken from number 1 from our worksheet or our homework. It says to graph the parabola x squared equals 16y. First step here is to solve for y. And so I'm going to swap 16y and x squared. And it's really a 1 times x squared. And then divide by 16, and you end up with y equals 1 over 16 x squared. So from this equation we can see the vertex, or find the vertex. The vertex is going to be 0, 0, because we don't have any number with the x in parentheses. We don't have any number added or subtracted after the x squared either. We just have that 1/16th, which we're multiplying by x squared. And that doesn't shift the parabola left or right. So we know we have a vertex at 0, 0. That 1 over 16, though, is equal to 1 over 4a. Or in other words, that 16 we can set equal to 4a. And find out that a is 4. A is the distance from the vertex to the focus. And that's going to be helpful with our graph here. So let's graph our vertex at 0, 0. Our focus, well, here our parabola we know is going to open up for 2 reasons. First, it starts with it's a y equals, and the y-axis goes up or down, and so we know it's either going to open up or down. And second, that 1/16th is positive, so we're opening in the positive y direction. So the focus always goes in the direction of the opening, so it's going to be 4 units above our vertex. So I'm going to labels. I'll put F next to focus, I'll put V next to vertex. And then the directrix is on the opposite side of the vertex, the same distance, that distance A from the vertex. So I'm going to go down 4 and to sketch our directrix. So the directrix is, in this case, a horizontal line. The vertex is dead center between the focus and the directrix, for a distance of 4 away from both. So we can now put our focus here at, the coordinate of our focus is 0, 4. The equation of our directrix, it's a line, it's a y equals -4. Make sure you have y equals, not x equals. And the focal chord endpoints, well, we're going to use a to help us find that. Actually, 2 times a, well, a is 4, so 2 times a is 8. That's the distance from the focus to the parabola in this case, moving left or right. So from our focus, I'm going to go right 8 and left 8. So 1, 2, 3, 4, 5, 6, 7, 8. And left 1, 2, 3, 4, 5, 6, 7, 8. And so we have this parabola here opening up. So it's a bowl shape. The focus is always inside that bowl. The directrix is somewhat like the table that the bowl sits on. And so we have our 2 points. The one on the left is at -8, 4, and the one on the right is at +8, 4. Part B is taken from number 7 in the homework, and it says to use the formal definition of a parabola to derive the equation of a parabola with a focus at 0, 4 and a directrix at y equals -4. So I'm going to start with a sketch here. So the sketch is going to have y equals -4. So there's our directrix. And our focus at 0, 4. And we need to use the formal definition of a parabola. The formal definition is the set of all points equidistant from both the focus and the directrix. So one point in particular we know is the vertex is the same distance from both, and then it just creates this parabola here. Something like that. So we'll pick a generic point on our parabola, point P, which is some generic x and y, and here's our focus, which is at 0, 4, and the distance right here, I'm going to use a different color. So here's a segment from F to our point here. And then I want to draw the distance from that point to our directrix, which is going to be a straight drop down. So let me redraw this so that it extends a little further. And so here, right there, that's on the directrix. The directrix is the line y equals 4. But that particular coordinate where they touch here is going to have the same x value, which we don't, it's just a generic one, with a height of -4. And we'll call that point D for the point on the directrix. And so by our definition, we know that the distance FP is going to equal the distance from P to D. Now using the distance formula, point F, you subtract your x values, so x minus 0 squared plus y minus 4 squared, that's my FP right there, is going to equal the distance from P to D. So that x minus x squared plus y minus -4 squared, double negative. Remember the distance formula in general between, let me write this out here, the distance formula between x1, y1, and x2, y2, the distance between them, d, is going to be the square root of the quantity. You subtract your 2x values squared plus you subtract your 2y values and square it. So that's what we're using to find these, to set this equation up. And so from this equation we're going to be able to derive our equation. So square both sides to get rid of the square root. And we have x minus 0 squared plus y minus 4 squared is equal to x minus x squared plus y minus -4 squared. And then there's a few other things we can do. We know that x minus 0 is x, so this is just an x squared, plus y minus 4 squared is equal to x minus x is 0 plus another y, well here we have a y plus 4 squared And so now multiply out our y minus 4 squared. So this is x squared plus y minus 4 times y minus 4 is equal to y plus 4 times y plus 4. Y minus 4 times y minus 4 is going to give us, so we got x squared plus y squared minus 4y minus 4y plus 16 is equal to y squared plus 4y plus 4y plus 16. So a few things we can cancel out here. We could subtract 16 from both sides. We can also subtract y squared from both sides. And now we're left with x squared minus 4y is equal to 4y plus 4y. Actually, I left a minus 4y out. So let me put that in there. Scoot that over a little bit. So that's x squared minus 8y is equal to 8y. Add 8y to both sides, you get x squared is equal to 16y. Swap sides. That's a 1 in front of the x squared. That's invisible. I'm going to write it there so that when we divide by 16, we get y as 1 over 16 x squared. You may notice this is the same exact problem we had in number 1.